In this question, we want to determine the minimum distance from that point to that line. So, using our max and min principles, we have a relatively lengthy solution that looks like this. We'll go through this step by step. We know that the equation of the line is shown here, which means that the y value is 5/2 x plus 5. Letting xy be the point on the line closest to 3, 8, we can see that the distance between them will be x minus 3 quantity squared plus y minus 8 quantity squared. We're looking for the distance from xy to 3, 8. So expanding this out and letting y equal 5/2 x plus 5, simplifying this bracket and squaring that, collecting like terms, we get that the distance between the points is the square root of this quadratic expression. Now, we want to set the derivative equal to 0. In order to minimize our work and avoid the chain rule, we're going to realize that the value of x that minimizes this quantity is also the value of x that minimizes the interior of the square root. So, what we're going to do is let capital D at x be simply 29 over 4 x squared minus 21 over x plus 18, as shown here. So, letting that happen and taking the derivative of that quantity, we see that x is 42 over 29. Now, the domain is x, any x element of the reals. We don't know where on the line xy is. So letting x approach negative infinity, we get a distance between the points of infinity, and letting x approach positive infinity, we get a distance between the points of infinity. So letting x be 42 over 29 gives us a distance between the points of 1.67. So we can say that the minimum distance from that point to that line is approximately 1.67 units.